All right, how many terms? Again, that's asking for n. So I can see that my u1 is 2. My r value appears to be 4. My nth term, 32,768. So I can plug into my formula. u1 times r to the n minus 1. You know, in this case, I could combine this all to make 1 because I know that 4 is the same as 2 to the power 2. So now this is going to become 2 to the 2n minus 2, but I have 1 2 over here, so I could say 2 to the 2n minus 1. And now I could do this with one log entry. So I can go into my shortcut menu, log base 2 of 32,768. All right, that's going to be equal to 2n minus 1. So I'm going to add 1, which of course gives me 16, divide by 2 gives me 8. So 32,768 is the 8th term. All right, now we have a 4th term and an 8th term. They're members of a geometric sequence. Find the first 3. Again, I'm going to use my formula. 250 is going to be the first term times r to the 3rd. 156,250 is going to be the first term times r to the 7th. Now, in this case to solve, I'm going to divide these two terms. I'm going to find the ratio, because when I find the ratio, then I get that my t's, my initial term, my t1s are going to cancel. So let's figure out what this is. 156, 250, divide by 250, 625 is r to the 4th. Therefore, my r value is plus or minus 5. Notice, even I have 2 answers, and nothing in my initial constraints tells me whether my r was positive or negative. So if r was positive 5, then my initial value, so 5 to the 3rd is 125. That means that my t1 would be 125. And then if it was negative 5, r cubed would have been 125. So then my initial t1 would have been 2. If I had negative 5, t1 would have been negative 2. All of my even terms would be positive. All of my odd terms would be negative in this case. So let's list our first 3 terms. We would have 2, 10, 50, or negative 2, positive 10, negative 50. So 2 possible answers for this one. Be careful with even exponents.